Hello everyone, today I'm going to show you how I made this project. So it's basically inspired by Panoply's work. We have an edge network and then we unroll packed primitives using this edge network. So basically we transfer animation from curves to the packed primitives. Also, I'll also be sharing the HTA that I made while I was working on this project. You can name your own price, but it's free if you don't have many money. Yeah, I'm joking. It's free, but if you want, you can drop some bucks here. Okay, so also I made this little edit while I was working on it. So yeah, please leave a like. Also check out my Behance project. It's my first project on Behance, so I'll really appreciate your like, your comment here. So yeah, let's get started. To actually install them, when you download this file from the Gumroad, you will be left with this folder, and then in here you will have your examples file showcasing different scenarios that these assets can be used. And also with the HTA folder in here you have your actual HTAs. So what you need to do, you need to copy them and then actually place them inside of your Houdini main folder in the documents and then the packages, and then just drag and drop them or copy and paste them in here. And then if your Houdini is launched, just reopen it, and then you will have your assets, which is edge network from packed and then the unroll curves. You'll be getting this example file with the asset itself, and in here it will be 4 examples. First one is basic cubes, the rubber toy example, the dummy example, and then also this kind of curved tree which transforms to the RBD. Okay, so let's start with the parameters. So basically when you install the asset in here, you will have AKA library, and then in here you'll have edge network and then the unroll curves. So first thing node you need to use is the edge network. So let's say you have those packed primitives here. So I just fractured fractured the cube, and then in here I have those fractured pieces. Okay, so let's say I want to generate the edge network from them. There you go. So as you can see, from the 0 point, which is somewhere here, so it always starts from the 0 point and then grows out. This is using like every mode here, doesn't really matter. The shortest path, this the same almost with the Vex, but the shortest path work with the kinefx type inside of the unroll curves. So every other mode like a Vex space colonization doesn't work with the kinefx, only the shortest path though. This is because other methods can result in this cycle. For example, what I mean by that is, for example, if you have your point here, it connects to the other one, connects to the other one, connects like that, and then connects to itself. Or you have like a multiple connections out of like a one curve. So this means like a cycle. And for example, if you use Rig Doctor here with the shortest path, basically Rig Doctor initializes the kinefx transformations. You will have like no problem. But if you switch to Vex, for example, there you go, it actually finds a cycle. This can be fixed by adding additional like a root point, but you know, if you have like a shortest path, why you want to do this? And then space canalization, it can like look like it's working, but it's actually not, because this method actually is a little bit more complicated than these two. And as you can see, it doesn't even find any edge network here, but I will talk about this later. Okay, so as I said, it starts from the 0 point here, and this means actually you need to sort your primitives. So let's say I have like long kind of cube here, and then I want to sort my primitives, my point number by y. So what that means is my first primitive would be at the bottom, and then the last primitive would be at the top. So this is exactly what we want. And if we look at the edge network, you can see our edge network actually starts from the 0 and it grows out to the top, or vice versa if you reverse the point number, or it grows from the x from the side and grows to the other side by using this by x. Okay, and then space colonization is actually a pretty important mode as well. This actually kind of like a solver. So if you increase the search radius, it will actually create the same thing, but it's more accurate. So if you have more tighter points located to each other, it actually can be more accurate than the others. And it also works by solving each frame, but I'm using this inside the for loop, and I also have a stop condition for them. So even if you put like 10,000s of iterations, it will not slow down your computer, because in this case it actually found a primitive within let's say within an iteration, as you can see. And I have a stop condition, so it finds all the points, connected all the points within 9 iterations. But for example, if you have a lesser radius, right? So in this case, you see those points are not found yet, and if you increase the iterations, now it can get slow. So use this like carefully. I guess 100 iterations should be enough for most situations, but it can be situations where you need to up this. So this is about edge network. And then the unroll curves, you plug your edge network to the first input, and as you can see, you have a problem because we are in the type kinefx. Those are the same, the parameters are the same. The only thing is change is in the kinefx. If you switch this transfer pact, you don't have any parameter, but in the custom vex you have a couple of parameters. I'll talk about this later. And also in the custom you have direction, amplitude, and scale. In the kinefx you have translation amount. Basically they act the same, but like for different method here. Okay, so let's say we generated those curves and then you want to unroll them. And in this case, as you can see, nothing is working for some reason. And I think the reason is because of what? Interesting. Maybe the points. Okay, strange. Maybe I broke this. I don't think so. Is it working here? Yes, it is. So there's something about, oh, of course, I know. We stick this transform pact, but we didn't specify any pact geometry here. So untick this, and there you go. You see? It actually nicely grows points within like a given pact primitives, which is really cool. Okay, so let's say we unroll this. We like specified our speed, our roll off, or animation ramp. This per piece offset. Basically for each point, it's actually offset is the animation by the amount here. And then you can use your custom amount. So you can, for example, cluster some of the points here, and then use this cluster attribute as an offset attribute here. I actually show this in one of those examples. I'll show you later. So yeah, and then you just put your geometry in the second input and make sure you have the same name attribute. So the name attribute should be present, okay? And then tick the transform, and there you go. They are actually growing. And the look is, of course, because our primitives are okay. You see, they are nicely growing. And then the sort, actually, if you do by Y, it will grow from the bottom. So this is basically how it works. So now let's look at the examples that I pre-created. You'll be getting this with the file itself. I'm just doing some cubes. I'm splitting this by noise. You can look at those nodes by yourself. They are actually nothing too crazy. Just subdividing in a for loop again, merging them, connectivity, just giving those each of those cubes its own unique name attribute, and then actually sorting this by Y, and then creating edge network. Here I'm also giving the random directions, so basically random normals, and then I'm using this in the unroll direction as an unroll direction attribute. And as you can see, for each of those cubes you have like a random rotation, which is actually controlled by this maximum unroll rotation. So if you turn this off, you see you have no rotation at all. If you turn this off, you have like this is in degrees, by the way. So for example, it will turn itself 45 degrees or like 90. So this can be specified. And as you can see here, you can see this more clearly with this per piece offset, as you can see. And then initial offset is just like controlling the ramp itself. And then the speed, of course, you can make it like slower or faster, whatever. Okay, so next example is our rubber toy. And here we're actually looking at the modeling side of it. So I'm just again doing some fracturing here, and those are like a cube-like pieces here. I'm sorting this by distance, and the distance attribute I actually generated in with this node. So I selected this point and then said like let me give from this point, give me the direction or along the geometry. And then in the assemble, I'm transferring this to the packed primitives. And in here, I'm just sorting this by this distance attribute. So you can see my first point is over here. It will be hard without this thing along geometry, because if you say like sort me by Z direction, it can find, for example, this piece as a first. So this is actually how you can control your fall off in this example. And then using shortest path, generating the edge network, and then making those directions. So this is pretty easy as well, just blasting some points, connecting them, creating this like an inner curve, resampling them, giving tons of points. And then in here I'm just doing its own position, so it gives me the normals that are pointing outwards of this curve, and then I'm just crossing this with the up vector, which is generated by this node. So at the end, I have something like this. As you can see, really nice animation here, and it's using Kinefix. And as you can see, the main difference between this and Kinefix is that the Kinefix actually moves our pieces, and it looks really nice, you know. And also this ramp is also controlling this. And the modeling part, as you can see, this is the main thing here. So what you need to do, you can run for loop for each of those fractured piece, and then you can do whatever you want with them. Okay, whatever you want, you know. for example, let me just have some edge here, let me have some inner pieces here, you know. And then what you need to do is you need to, at the end, you need to pack them and then copy your original name attribute back to those packed prim, and then just promote this to the point, and then it will perfectly work. As I said, you can look at those examples by yourself because the file would be with the assets itself. And then they told me, again, here I'm just showcasing this cluster attribute. Let it cook a little bit. Okay, so it's cooked, and I'm just again doing some fracturing, but in here I'm actually painting some attributes, blah blah blah. It doesn't really matter. What matters is this cluster attribute. So just random directions in sketching around 60 points and using this cluster. So what cluster does, it actually gives you a random cluster attribute for each of those. For example, let's say you have a point here, right? This is your point. Okay, this is your point, right? And then the cluster of this point will be like this region, right? And then you have a scattered point in here as well. So this will be your clustered area. So for each of those areas, you will have a different attribute. So we can generate a random attribute using this. What needs to be done is your offset piece attribute should be a string. So this is important. So you can use something like this to convert integer to the string. And if you turn this off, okay, you have your simple random by each primitive here, just like simple stuff. But if you turn this off using index, you can see for each of those clusters, as you can see, you have a different random offset, and this is really cool, you know. And in here I'm just, you know, merging two different methods, which is KineFX and then the CustomVex, and this is the example itself. And then the third one, my favorite. So you have initial curves, we scatter some spheres on this, and then we do a simple RBD sim here. They are just falling. And what's important here is I'm giving for each of those curves, I'm giving a random index attribute, and also I'm generating this curve view attribute. So by default, if we turn off everything here, you can see those curves are actually like they are growing, but you know, they are growing strangely, you know. But if you use this distance attribute, basically, as I said, this is just a curve view attribute on the curves. You can see now it's totally different result, and you can control this result easily. You can see pretty nicely, isn't it? And then if we use offset index, now you have for each curve you have a different value, you see. And then you can use these transform pieces to merge the simulation and then the unrolling, and you will have cool animation like this. Pretty cool. So the way those structures was generated is not too different from this. Again, I will not be covering everything because this is like basically the same stuff that Simon did in his presentation, just deleting pieces that are close to the outside shell of this box using this wrangle, and then you are actually left with stuff like this. And then you do your sorting, and then you do your edge network, and then with the unroll curves you just transfer those back, those primitives. And basically, as long as you have your name attribute at the place here, there will be no problem, because this node will handle everything you need without any problems. The way you keep the name attribute is basically you run a loop for each of those individual copied pieces. Inside you just unpack them, and then you do all of your modeling stuff, like you know, the shells, the webs, and then the panels itself. You merge them together, you delete unnecessary attributes, and then you pack them. And as you can see, you don't have any name attribute. And the trick is here is this is merge in loop. So basically I'm just merging this node, and this node actually have a name attribute on the primitives. And what I'm doing here is I'm just saying, let me just, you know, copy this back to my already modeled piece. And because this is our just packed, this is just one point, so the order of this name attribute will be the same, and there will be no problem. So as long as you have your original name, so in this case this name attribute was 29, so piece 29, and then in here again you will have the same piece 29. Okay, and yeah, so you just, you know, use this unroll curves and you have those pieces. Again, I'll be sharing the basic example of this with the file, with the HTAs itself, but again, as I said, there is nothing too crazy. The reason for me to focus on different scenarios of using those assets was just to showcase you that this thing can be used not only for, you know, creating this type of stuff, right, but this can be used for many like different scenarios. You can see, for example, revealing this hand is like pretty good, you know, and the same thing with the, you know, these curves as well. So this node can be used in different ways, and I encourage you to do so, and feel free to share your work with me. Feel free to use those assets in any matter. But the thing is that this works in the latest Houdini build. You can try it in the builds before, and also of course this is like in the file. So if you have like a, you know, Houdini FX, it will not work. You need to launch this in the indie, but I guess that's not a big deal because most of us are actually using the indie here. So yeah, that's pretty much it. Thank you, and yeah, leave a like and also check out my Behance project. Any feedback will be appreciated. Thank you.